construct a 90% confidence interval for the mean mu, population mean. Assume that the population has a normal distribution. A sample of 15 randomly selected math majors has a grade point average of 2.86 with a standard deviation of 0.78. Right, so with this given information, so we have to construct 90% confidence interval. So first extract the information. So sample size is 15, so n would be equal to 15, and the grade point average of that sample is 2.86. So x bar is 2.86, and standard deviation of that sample s is equal to 0.78, and we have to construct 90% confidence interval, right? So for the population mean mu. So first degree of freedom here. So if n is 15, so then TF or degree of freedom, this is always n minus 1, so that's equal to 15 minus 1, which is 14. And our confidence interval for this problem would be x bar plus minus, then it's t sub alpha by 2, and then s by square root of n. So we have to find, now you see that x bar is given already, right? So s is given, n is given, so we have to find this t sub alpha by 2. So because the confidence interval is 90%, so it means that alpha is equal to that remaining 10%. So alpha by 2, that is equal to 5% or 0.05. So this t sub alpha by 2, that would be equal to t sub 0.05. So this value we have to find. And we can read that this value from the t distribution table with the 14 degrees of freedom and this area on the right tail, this 0.05, right? So this would be this number here. So this is telling us the area on the right tail for the t distribution table. So for example, if you want to visualize it, so it would be something like, say, this is t value, t distribution curve, and say if this area here, this is 0.05, so then this would be t.05. And now we can read this value from the table. So this is a t distribution table, and our area was 0.05 in the right tail, right? So this is the area in the right tail, and so our value would be in this column, right? So in this column, so we have to choose value corresponding to degree of freedom 14, and this is a column for degrees of freedom, and our degree of freedom is 14 here. So it means that we would be looking in this row, right? So this row here, and in this column, so if you see that, so in this intersection, the value is 1.761. 1.761. So this is our value, t value. And now the confidence interval would be with this equation. So x bar is 2.86. It would be 2.86 plus minus. So t sub alpha by 2 is 1.71, and s is 0.78, and divided by square root of 15, so n is 15, and that's equal to 2.86 plus minus. So this part here, so this would be simplified into 0.35. So now we have to one time subtract 0.35 from 2.86, and one time we have to add, and when we subtract it, so we would get the value 2.51, and once we add, so that would be 2.21. So this is our 90% confidence interval for the population mean.